In this video, we're going to show you the traditional algorithm for multiplying decimals. This is the way that your parents are familiar with. So we're going to do an example together.
Our first problem is going to be 1 4/10 times 2 3/10.
Your first step is going to be to rewrite the problem with no decimals in it, because you're not going to worry about the decimals at first. So it's just going to be like multiplying 14 times 23.
So now you're going to use the traditional method to solve this problem. So you are going to start in your ones place. 3 ones times 4 ones equals 12 ones. Okay, regroup. And 3 times 1 we know is 3 plus our extra 1. We have 4 tens. Then we're going to work with the 20 times 14 now. So we have to hold our place. So we're going to put a 0 in the ones place because we're really doing 20 times 14, but now we've got that 0 there, so now we're going to say 2 times 4 is 8, 2 times 1 is 2. All right, then we add our two partial products. And we've got 2, and then 4 plus 8 is 12, regroup, and 300. So we have 322.
All right, so that's with taking the decimals out. The way to put the decimals back in is to look at your original problem, and you are going to count how many digits are behind a decimal. So we're going to look at this. We have 1 digit behind the decimal, 2 digits behind the decimal. So we're going to go into our product over here, and every whole number has an imaginary decimal at the end. So we're going to move it 2 places to the left. So our answer will end up at 3 2/2200. So if you look, there was 1 behind the decimal, 2 behind the decimal, and I have 2 behind the decimal in my answer.
Let's go ahead and do this same problem, but we're going to do it using partial products, multiplying with partial products. We have 1 4/10 times 2 3/10. We will rewrite the problem, and we will forget about those decimals even being there. So we're going to multiply 14 times 23. Well, we can go ahead and break up our 14. So we'll do 23 times 10, which I should be able to do that in my head, and 23 times 4, because 10 plus 4 will give us 14. 23 times 10 will give us 230. And 23 times 4, 4 times 3 is 12. Regroup with our 1. 4 times 2 is 8, plus our 1 is 9. Now we will add our two products together. 230 plus 92. 0 and 2 is 2. 3 and 9 is 12. Carry our 1. 1 and 2 is 3.
And then you go through the same process. You look and see how many are behind the decimal. 1, 2. So we're going to make sure 2 are behind the decimal in our final product. You get the same exact answer. All right, our second example, we're going to be doing $5.25 times 6. So if you can imagine, you went to the store to buy 6 of something, and each item cost $5.25. So we're going to rewrite the problem with no decimals. And this way is going to work for both the partial and the traditional algorithm because there's nothing to break apart. So we're going to only have to do it this one way for everybody.
So the first thing that we will do is we will multiply 6 ones times 5 ones, which is 30. Write our 0 down, do our plus 3. 6 times 2 is 12, plus 3 is 15. Regroup with our 1. 6 times 5 is 30, plus 1 is 31. So we get 3,150. However, we need to go back and look how many numbers are behind how many digits are behind our decimal.
So we have our 2 digits behind the decimal, those 25 cents. So we've got to add in our decimal. We're going to have 2 digits behind our decimal in our product. And if you think about it, this makes sense because we're dealing with money. $5.25, 6 times, well, the answer should be approximately $30, a little bit more, $31.50.
If you were to ever think when you're multiplying money and you somehow get more than 2 digits behind the decimal, you've done something wrong, because as Ms. McDaniel was saying, it's money. There's only going to be 2 places behind the decimal point in money. So remember that. Now on the student side, we're going to give you one to practice doing either the traditional algorithm or the partial products algorithm.
We'll go ahead and give you 3 and 5/10 times 2 and 9/10. Go ahead and try this on your own either way.